Hello and Assalamualaikum. My name is Nur Adrana Kaisara binti Muhammad Rashid. My matrix number is 01DEE25F1018.
Assalamualaikum and hi everyone. My name is Darusha binti Faizal. My matrix number is 01DEE25F1026.
Assalamualaikum. My name is Nur Ashifa binti Radnan. My number matric is 01DEE25F1028.
Introduction. Vectors are fundamental elements in mathematics and physics that describe both the size and direction of a quantity. In three-dimensional space, they allow us to represent positions, movements, and force with precision. Whether modeling the path of an object, the orientation of a structure, or the interaction between components, vectors provide a clear and structured way to analyze spatial relationships. In this presentation, we will explore how vectors can be used to examine a road placed in a corner between two walls, focusing on how to calculate its length and the angle it makes with the floor using vector operations. So as we begin, keep in mind that vectors aren't just numbers, they are tools that help us understand how things move and interact in space. Let's look at what we aim to achieve. The objective of this presentation is to apply vector principles to analyze spatial relationships in three-dimensional geometry. It focuses on representing positions using vector notation, calculation distance between points through magnitudes, and determining angles between directional elements using the dot product. This approach demonstrates how vectors can be used to interpret orientation and structure within a defined coordinate system. This objective will guide us through the problem-solving process. Now, let's look at the specific question we will be working on. The question: a road is placed in a corner formed by two perpendicular walls. One end of the road touches the floor at point A, which is 4 feet along the x-axis from the origin. The other end touches the wall at point B, located 4 feet up along the y-axis and 2 feet along the z-axis from the origin. A. Find the vector AB that represents the road. B. Calculate the length of the road using the magnitude of AB. C. Determine the angle theta between the road and the floor using the dot product, where the floor vector is phi, which has components 4 in the x direction, 0 in the y direction, and 2 in the z direction.
So this is a figure vector in 3D space. We can see that position vector is x, y, and z. Next position vector of point A is 4, 0, 0. And position vector of point B is 0, 4, 2. Let's look at the question A. The question A is to find vector of AB. To find vector of AB is equal to OB minus OA. Is 0x plus 4y plus 2z minus 4x plus 0y plus 0z. And the final result is negative 4x plus 4y plus 2z. Next question is to find length of the road AB. To find vector AB is equal to square root x square plus y square plus z square is equal to negative 4 square plus 4 square plus 2 square and get square root 36. And final result is 6 feet.
So for the last question, we need to find angle theta between the road and the floor. First, we need to find the total of unit vector in the diagram. Calculate unit vector for AB and V. So, negative 4x plus 4y plus 2z times negative 4x plus 0y plus 2z gather the same coefficient together, so we got 20. Now we need to calculate the magnitude of v using the formula square root x square plus y square plus z square. Put in the value negative 4 square plus 0 square plus 2 square. So the magnitude of v we got is square root 20. The last step is we need to use the formula of cos theta equals to unit of vector AB times unit of vector V per magnitude of AB times magnitude of V. Just put in the value that we have calculated before. So the angle of theta between the rod and the floor is 41.8 degree.
In this example, we have demonstrated how vectors can be used to analyze a physical object in three-dimensional space. By representing the rod as a vector, we'll calculate its length and determine the angle it makes with the floor using vector operations. This approach is widely applicable in fields such as engineering, architecture, and physics, where understanding spatial relationship is essential. So, whether you are designing a structure, analyzing motion, or solving geometric problems, vector operation give you the precision and clarity needed to understand how objects interact in space